with Mr. Thomas.
Why, aye man! Here we are with chapter 4, lesson number 3, separating the variables 3. But this time we're now looking at the particular solution. Woo! So the first thing we need to do is we need to think what is meant by a particular solution. So, you know, when you integrate, you will have, on the end, a constant of integration. In other words, a plus c. And if you get back to y equals and you have your plus c, well, that is known as your general solution. However, sometimes you will be given an initial condition such as a point that lies in the curve, and if you have that, well, your point will have an x and a y value. You could sub them into your general solution and that will let you find the value of c. Woo! If you do that and you find out what c is, well, then you can sub c into the general solution and you will have what is known as the particular solution. So your general solution is going to be of the form, it may look like y equals x plus c. If you knew what x and y were, you could sub them in, find out c, and then sub that in. So your particular solution would possibly look something like y equals x plus 5. In other words, you've found c and you subbed it in. So let's look at some of these examples solving differential equations, but separating the variables. So, example 10, find the particular solution of the differential equation x squared dy by dx equals 4x squared plus 1, given that y equals 2 when x is 1, expressing y explicitly in terms of x. So, examples 1 to 9 are in the first 2 lessons. This is just another example of solving differential equations, but we're going to be looking for the particular solution. The first thing that you have to do, Chelsea, help us out. Perfect, you want to separate the variables. So, separating the variables, we can see that we've got y squared and dy on this side, we've got 4x squared plus 1 on this side. Really, y is over here, x is over here, but we've also got this dx. So, let's multiply both sides by dx. If you do that, then you will end up with y squared dy equals 4x squared plus 1 dx. Now, you can see the variables have been separated. High five! From there then, where do you go? Perfect, you will now integrate both sides. So we want to integrate y squared dy, and we're integrating 4x squared plus 1 dx. Doing that then, integrate y squared, that will just be y to the power of 3 over 3, or a third, y cubed. Integrate 4x squared, well, x squared will go to x cubed, divide by 3, so we'd have 4 over 3, x cubed, and you will have plus x if you integrate 1. And we know in the end we will also have plus c! You got it! From there, what it would do, nobody likes fractions, so let's get rid of these fractions by multiplying every single term by 3. So if you do that, well, you will end up with 1y cubed. That will equal 4x cubed plus 3x plus, good, it's going to stay as c. Remember, c is just a constant. If you multiply the constant by c, it's still going to be just a constant, so you can leave it as plus c. That there is your general solution. I suppose you could rearrange it to get y equals, but we've got this plus c. We now have more information. We're told that y equals 2 and x equals 1, so we can sub them into this general solution. So replace y with 2, replace x with 1. Therefore, y cubed equals 4x cubed plus 3x plus c becomes 2 cubed plus 4 times 1 cubed plus 3 times 1 plus c. Work that out and you get 8 equals 7 plus c. In other words, c equals 1. And because we know c equals 1, we can sub that back into the general solution. So we'd have y cubed equals 4x cubed plus 3x, and instead of plus c, we'd have plus 1. Let's take it one step further. If you did have to get down to y equals, then you could have y equals. We're taking the cube root of y cubed in order to get to y, so we will take the cube root of the other side as well. Or you could write it as that other side to the power of 1/3. Example 11, find the particular solution of the differential equation dy by dx equals 2xy squared, given that y equals negative 3/10 when x equals negative 2, expressing y explicitly in terms of x. So the first thing again, how do you solve this differential equation? Help us out, Valley, what would you do? Perfect. For that, you would separate the variables. So, multiply both sides by dx. From there, we've got y's over here, we've got x's over here, but we've also got the y squared. So divide both sides by y squared. Therefore, we will have 1 over y squared dy equals 2x dx. And we can see the variables have been separated. Woo! Party time. From there then, we will integrate both sides. So we're integrating 1 over y squared, but remember to integrate it, you want to write it in a form you can integrate it. So you will have y to the power of negative 2. We'll integrate that, and we'll also integrate this 2x with respect to x. Doing that then, y to the power of negative 2, if you integrate that, it'll go to y to the power of negative 1, divide by negative 1, just move the negative to the front. 2x squared, if you integrate that, will be 2x. If you integrate it, will go to 2x squared divided by 2, which will leave you with x squared. And we'd also have plus c. You could rewrite that y to the power of negative 1 as 1 over y. That would still equal x squared plus c. And from there, well, really, you don't want the negative on the y side, so let's multiply through by negative 1. If we multiply through by negative 1, we'd have 1 over y, and that would equal negative x squared, and plus c will change to? You're right, it won't. It will stay as plus c. You're still adding on some constant. The constant can be positive or negative, but it's still saying, look, there may be some constant, so just leave it as plus c. After that, to get y, well, y is going to, if you rearrange that, you will have it equal to 1 over c minus x squared. You're just going to rewrite that. Multiply both sides by y, so you'll have 1 equals the negative x squared plus c in brackets times y, and then to get y on its own, divide both sides by the negative x squared plus c. Or you could rewrite that as c take away x squared. So you'd have 1 divided by c take away x squared. That there is your general solution. We want, though, the particular solution. So to get the particular solution, look at the other information we are given. We are told that y equals negative 3/10 and x equals negative 2. So we can replace y with negative 3/10, replace x with negative 2, and therefore the only unknown will be c. So we can work that out. So taking this general solution, replace the x and the y will give us this. Let's take our time just going through that then. So negative 2 squared, if you work that out, it will give you 4, so you'd have c take away 4 just on the bottom there. If you multiply both sides by c take away 4 and multiply both sides by 10, or in other words cross multiply, you get negative 3 times c take away 4 would equal the 1 times 10. Multiply the brackets, negative 3c plus 12 equals 10. You can therefore work out the value of 3c, and you can therefore work out the value of c. So c would work out to be 2/3. After that, because you know this value of c, you can sub that back into your general solution. So you get y equals 1 over 2/3 take away x squared. And rewriting that, well, if you multiply each of the terms by 3, you will get 3 over 2 minus 3x squared. And that there will be your answer. Example 12. Find the particular solution of this differential equation. X plus 4 in brackets dy by dx plus 1 equals y, given that y equals 7 when x equals negative 1. Once again, expressing y explicitly in terms of x. And the first thing that we do, help us out. Well done, we separate the variables. So, separating the variables, we are starting off with this. Undo anything you add or subtract. So, subtract 1 from both sides. That just makes this easier. From there, you can see we've got x's on this side, but we've got y's as well. So we still need to rearrange that. What I would do, first of all, is just multiply both sides by dx. Therefore, you'd have x plus 4 dy equals y take away 1 dx. Then, what you want to do is you want to divide both sides by x plus 4. and divide both sides by y take away 1. If you do that, you will end up with, on the left hand side, 1 over y take away 1 dy. And if we divide both sides by x plus 4, you'd have 1 over x plus 4 dx. So, you can see now that the variables have been separated. Woo! So, from there, where do we go? Yes, you integrate both sides. So we're integrating 1 over y take away 1 dy, and we're integrating 1 over x plus 4 with respect to x. So integrate 1 over y plus y take away 1, well that just becomes ln y take away 1. Integrate 1 over x plus 4, well again that goes to ln x plus 4. And on the end, don't forget it, everybody loves it, plus c. After that, well really you want to try and get down to y equals. So how could you go about doing that? You can see here that we have the natural log ln. So to undo the natural log ln, we need to think about its inverse. And the inverse of ln is your exponential, e. So let's take e, the exponential of both sides. So we'd have e to the power of ln y take away 1. And that would equal e to the power of that right hand side. The ln x plus 4 and the plus c. Doing that, if you think about your rules, well, you've got ln x plus 4 plus c and it's e to the power of both of them. So what you can do with that is you can say, well, that could be split up. So it's e to the power of ln x plus 4 times e to the power of c. So you can write it as that. From there, well, just remember your exponential and your log, one's the inverse of the other. So really, they will cancel. So e ln will just disappear, leaving you with y take away 1. ELN again will disappear, leaving you with x plus 4. And we're still timesing that by e to the power of c. Do you remember what e to the power of c, how you would write that? Perfect. You would just write that as a. So e to the power of c, you would just write as a. So y take away 1 would equal a times x plus 4. From there, you want to get y just on its own, so add 1 to both sides, and therefore y would equal a times x plus 4 plus 1. Woo! We now have y equals. From there though, we are not finished because we have to find this particular solution. And to find the particular solution, look at the extra information. We're told y is 7 when x is negative 1. So, replace y with 7, replace x with negative 1, and the only thing missing will be a. So if you do that, you will get 7 equals. That will become negative 1 plus 4, which is 3. So it's 3 times a plus 1. Therefore, 3a would equal 6, and therefore a equals 2. Once we know this value of a, we can sub that back in. So we'd have y equals, instead of a times x plus 4, we'd have 2 times x plus 4, plus 1, obviously. And then you could multiply out the brackets and simplify, giving you y equals 2x plus 9. And that there will be your answer. Example 13, express 2 over y plus 1 bracket y plus 3 in partial fractions. Woo! Bringing in more partial fractions from the first chapter. And B, hence find the particular solution of the differential equation. 2x dy by dx equals x plus 1, y plus 1, y plus 3, given that y equals negative 5/3 when x equals negative 1, expressing y explicitly in terms of x. So, how would you start this one off? Well, if we're writing this in partial fractions, you can see that the denominator contains distinct linear factors. Ooh. So, we can therefore say that 2 over y plus 1 times y plus 3, we can split up to become a over y plus 1 plus b over y plus 3. If you're unsure of partial fractions, look back to that first chapter for a recap. If you're okay with it, let's move on. So we want a over y plus 1 to be on the denominator y plus 1, y plus 3. So we're missing this y plus 3. So to get y plus 1, y plus 3 in the bottom, we can multiply both the numerator and denominator by y plus 3. So a y plus 3 over y plus 1, y plus 3 plus... And then b is over y plus 3, but again we need this same denominator. We need it to have the y plus 1 as well. So multiply the numerator and denominator by y plus 1. Because the denominators are now the same, what do we do with the numerators? Add them! Perfect, we add them. So we'd get a times y plus 3 plus b times y plus 1 over y plus 1 y plus 3. And if we look at the left-hand side and the right-hand side, we can see that they are equal. And the denominators are equal. We've got a y plus 1, y plus 3 on both sides. So cancel the denominators. In other words, if the denominator is the same, the numerators will also be the same. So 2 must equal a times y plus 3 plus b times y plus 1. And now we need to work with that. So we need to find the values of a and b, and to do that, choose certain values of y. So let's first of all think, right, well, let's eliminate this bracket here. So that will eliminate a. To do that, we'll let y equal -3. If we do that, that will give us 0 times a, which will give us 0a, and it will disappear, and it will let us find the value of b. So we'd have 2 equals, that does become 0a, and then if y is -3, -3 add 1 is -2, multiply that by b, and we'd have take away 2b. Therefore, rearrange that, and b works out to be -1. Now let's eliminate b. So doing that, what value would you choose for y? Perfect. Let y equal -1. Doing that, we'll eliminate b. So if y is -1, you'd have 2 equals, and that becomes -1 plus 3, which is 2a, plus, and then that becomes 0b. And again, you can find that value of a. Once we know a and b, well, we wrote our partial fractions as a over y plus 1 plus b over y plus 3. Because we know the values of a and b, we can sub them in. So a over y plus 1 from the last page becomes 1 over y plus 1, and b over y plus 3 becomes -1 over y plus 3. But with the negative, just take that to the side. So it becomes take away 1 over y plus 3. So we have now expressed that fraction in its partial fractions. Moving on to part B, hence find the particular solution of the differential equation 2x dy by dx equals y plus 1 y plus 3, given that, well, we know x and we know y. So where do we go from there? Well, if we're wanting to solve a differential equation of this form, we will separate the variables. So to separate the variables, I would start off by multiplying both sides by dx. So we have 2x dy equals y plus 1 y plus 3 dx. Then we could divide both sides by 2x and divide both sides by the y plus 1 y plus 3. So we'd be left with, or if we left the 2 there and just divided by x, we'd have 2 over y plus 1 y plus 3 dy would equal, and if we just take the x over, we'd have 1 over x dx. So we have now separated the variables. So after we separate the variables, where do we go? Perfect. You integrate both sides. So we want to integrate 2 over y plus 1, y plus 3, and integrate 1 over x as well. However, what do you notice about this? Perfect. You can see here that this part is going to be what part A was all about. So part A asked us to express 2 over y plus 1 y plus 3 in its partial fractions. So the answer for part A we can replace this with. So using the answer from part A, that will give us the integral of, and then we saw that 2 over y plus 1 y plus 3 was equal to 1 over y plus 1 take away 1 over y plus 3. So we're just replacing that with the answer for part A. And that will still equal the integral of 1 over x dx. After that, where do you go? Well, we're going to have to integrate. So let's integrate 1 over y plus 1. That goes to ln y plus 1. We'd have take away, integrate 1 over y plus 3. That'll give us ln y plus 3. And if we integrate 1 over x, we'd have ln x. And we need your plus c. From there, think about log rules. We've got ln something, take away ln something. So we could apply the log rules here, and that will become ln y plus 1 divided by y plus 3. And that will still equal ln x plus c. Where do we go from there? Well, we need to really get rid of ln, and to do that, you need to think about your exponentials. So let's take the exponential of both sides. So we'd have e to the power of ln y plus 1 over y plus 3 equals e to the power of ln x plus c. Once again, because we've got e to the power of something plus something or minus something, we can split that up. So that will become e to the power of ln x times e to the power of c. From there, well, e ln, one is the inverse of the other, so they will cancel out. So we will be left with, if we cancel the exponential and the log, we'll have y plus 1 over y plus 3. That will equal, again, e and ln will cancel, leaving us with x times, and e to the power of c will stay as e to the power of c. Or will it? Perfect. E to the power of c, as you remember, that is equal to a. So we'd have a times x. What we want to do now is we want to get y just on its own. So we've got y plus 1 over y plus 3, but we want to have y equals. So to do that, what we need to do first of all is we need to multiply both sides by the y plus 3. So that eliminates the fractions and leaves us with y plus 1 equals a times x times the y plus 3. From there we can multiply the brackets. So we have y plus 1 equals axy plus 3ax. What we now do is we can take any terms with a y in them to one side and all the other terms to the other side. So doing that, we will have y take away axy, and if we subtract 1 from both sides, or move the 1 over, we'd have equals 3ax take away 1. After that, you can see you've got y here and you've got y here, so we can take it out as a common factor. So we have y times 1 take away ax would equal 3ax take away 1. And from there, help us out, Erin, where do we go? Perfect, you can divide both sides by 1 take away ax. Therefore, y equals 3ax take away 1 over 1 take away ax. That there, what's that called? General solution! Perfect, that's your general solution, but we want the particular solution. If you look at the question, we were told that y equals negative 5/3 when x equals negative 1. And because we know x and y, we can sub them in here. Woo! And therefore, the only thing missing will be a, and we can work it out. So doing that, replace y with negative 5/3 will give us negative 5/3 equals 3a times x, but remember x is negative 1, so sub that in as well, and sub it into this x here. So we have 3a times negative 1 take away 1 over 1 take away a times negative 1. After that, we'll just tidy that up slightly. We'd have negative 3a take away 1 over 1. Two negatives make it positive, so it'd be plus a. After that, well, again, what you need to do is you need to think, I need to find the value of a, so we need to get a really just on its own. So cross multiply here, multiply both sides by 1 plus a, and multiply both sides by 3. That will give us negative 5 times 1 plus a equals negative 3a take away 1 times by the 3. We're just cross multiplying. So you're moving the 3 over up here and you're multiplying, and move the 1 plus a to this side and you're multiplying there. I guess rid of the fractions. After that, multiply the brackets. So negative 5 take away 5a equals negative 9a take away 3. Move all the a's to one side, so if you add 9a to both sides, we'd have 4a on the left, and if you add 5 to both sides, we'd have 2 on the right hand side. If 4a equals 2, then a would equal 1/2. And from there, because we have now found the value of a, we can sub that into our general solution. So we will have y equals 3a to the times x becomes 3 times 1/2 times x, or in other words, 3 over 2. X, we've still got take away 1, and we'd have 1 take away ax, replace a with 1/2, and is 1 take away 1/2 x. Tidying that up slightly, well, if you take each term here and multiply by 2, it will eliminate the fractions within the fractions, so we'd have y equals 3x take away 2 over 2 take away x. You're just multiplying each of these 4 terms by 2, and that there will be your particular solution. Try these questions. You're separating the variables but looking at particular solutions. Give the questions a shot. It's the Unit 1 booklet, pages 83 and 84. If you still need the booklet, just send me an email and I will fire it out to you. Best of luck. Have fun. Bye.